Good day and welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Tracy Cook.
Thank you so much. Hello everyone and welcome to today's webcast, Secrets of the Agile Scaling Gurus, sponsored by Construx. I'm Tracy Cook with adtmag.com and I'd like to thank you all for joining us. Before we begin, let me take care of a few housekeeping details. Please feel free to type your questions into the Ask a Question box on the console at any time during the presentation. We'll address as many of your questions as we can during the live event. This webcast is being recorded and will be archived for future viewing. And to access the replay, you can use the same link you used today, and it should be available tomorrow. And now on to our speaker, Steve McConnell, CEO at Construx Software. Steve consults to a broad range of industries, teaches seminars, and oversees Construx software development practices. Steve is best known as the author of Code Complete, which is considered by many to be the best software development book of all time. Readers of Software Development magazine named Steve one of the 3 most influential people in the industry alongside Bill Gates and Linus Torvalds. In addition to Code Complete, Steve is the author of Software Estimation, Professional Software Development, Rapid Development, and other titles. His books have won numerous awards for the Best Software Development Book of the Year. His most recent project is an ongoing lecture series called Understanding Software Projects. Steve is making those lectures available to those who have registered. They'll be free for the next 90 days, and we'll send you an email to access them. So it's always a great honor to have Steve with us, and it's my pleasure to introduce Steve. Steve, please take it away.
Thank you, Tracy. Well, it is my pleasure to be here today to talk about Secrets of Agile Scaling Gurus. This is obviously a topic that's on a lot of people's minds these days, and certainly something that we have had an interest in for a long time. I thought I'd start by sharing my company's first experience with scaling way back in when we were getting started in 1996. One of our first engagements was with a startup company that had started literally with 2 guys in a garage, not just figuratively, but actually 2 specific males in a garage. And they had grown over a few years to a technical staff of about 50. And the rest of the story was actually kind of, from a scaling point of view, kind of a cliche. We engaged with the founder of the company, and he was really concerned about the fact that his staff was nowhere near as productive as he and his partner had been when they had started the company years earlier, and it was just 2 guys working. He felt like they weren't productive, the quality wasn't as good, they weren't making progress to the same degree, and all of that turns out to be a little bit cliched when we talk about scaling. So with that as prologue, before we get too much further into the topic, I should probably say what I mean by agile scaling. And certainly one approach that companies might use the word scaling to talk about is propagating agile practices across a bunch of standalone projects, none of which are very large, maybe just lots of individual Scrum teams. And that's not what I'm talking about today. I wouldn't even call this scaling. I would call it agile adoption or agile propagation or something like that. And so that's not what we're going to talk about today. What I would like to talk about today is really conducting a large project where agile practices are used a lot across the large project, and all teams are contributing to a single code line. So that is the focus of this talk. Now, of course, in many organizations, we have more of a federated approach to projects where we have a mix of individual small agile projects and larger multi-team agile projects. And so that really also is the focus of this talk, as insofar as it applies to those larger teams. So what I want to do today is I want to present 3 tools that can be used for understanding scaling. And those 3 tools look like this. First, I want to introduce the 4 factors lifecycle model, which is the model that's described in the Understanding Software Projects lecture series that Tracy mentioned in the introduction. Then I want to take a little bit of a look at the Cocomo 2 model, which is putatively focused on estimation, but for our purposes today, we're going to take a look at some factors that shed some light on scaling. And then I want to talk about activities and an intellectual phases profile model that I think is also useful for helping to get a handle on what we need to be concerned about as we scale projects. So turning into that first tool, the 4 factors lifecycle model, this really is something that I talk about in my lecture series, Understanding Software Projects. And as Tracy mentioned in the introduction, if you're attending this webinar live, you'll get 90 days of access for free to the lecture series. We've got about 40 lectures in that series at this point. We have about 30 or 40 more lectures planned, so it's a fairly extensive lecture series. But for our purposes today, what I want to focus on is the size factor in that 4 factors life cycle model, so that one shown in the upper left, and to some degree also show how size connects with or interacts with the other 3 factors in the 4 factors life cycle model, so how size interacts with uncertainty, defects, and human variation. I think actually when we talk about scaling Agile projects, understanding the ins and outs of software size is important to understanding software project dynamics, period, not just Agile projects, but any kind of project, and certainly the difference between large projects and small projects. And so what I'm going to do in this section of the talk is describe dynamics related to software size, which should shed some light on scaling Agile projects as well, or doing any kind of software development work at scale. But these days that normally means Agile. The guru's secret number 1, I guess I have to actually share some secrets since the title of the talk is Secrets of Agile Scaling Gurus. Secret number 1 is large projects are difficult. This is just a fact. If we look at industry data on project success rates, this is some data that's presented by Capers-Jones. You can see that for the smallest projects, and these are quite small, 500 to 1,000 lines of code, we have a really good chance of delivering on time or early and very little chance of delivering late or failing outright. But as the project sizes get bigger, that percentage of projects that are delivered late or fail increases, and the number of projects or the percentage of projects that are delivered on time or early decreases. And by the time we get out to the very largest projects, and these are really very large, 5 million to 10 million lines of code, we actually have a very small percentage of projects that are delivered on time or early, and more than half of projects fail outright, meaning they're canceled without delivering any useful functionality, before they deliver any useful functionality. And so, of course, this is quite a terrible state of affairs, and so that just reinforces the idea that large projects are difficult. So what is difficult about large projects? Well, or what makes them difficult? Well, prioritizing hundreds of requirements or backlog items and all the interactions among those, dividing those across multiple teams can be difficult. Tracking dependencies across multiple teams is an issue that gets harder as project sizes increase. Coordinating all the different deliverables gets harder as project size increases. Keeping increasing numbers of stakeholders involved and informed and cooperating with each other becomes increasingly difficult. Even things like sharing progress or status with the business or making best use of specialists or other resources becomes increasingly difficult as project sizes increase. So that really brings us to our second Agile secret of the Agile scaling gurus, which is avoid scaling if possible. Reason number 1 for avoiding scaling if possible is the failure rate's really high at large project sizes. If we can do a project as a smaller project, we should, because our chance of success is so much higher. Reason number 2 is as project size increases, error rate increases, not just the total number of errors, but the error per line of code increases. And at the largest size projects, the error rate is dramatically higher than it is for smaller projects. Reason number 3 is that productivity decreases. As we get into larger projects, you can see that at these large projects of 100,000 lines of code or 1 million lines of code, the range of productivities is lower. But if you take a look at the little diamond on the diagram, that's actually the nominal outcome, and that's quite low. The nominal outcome is much closer to the worst outcome than to the best. And so really productivity at larger project sizes is something that we really have to take into account as not being very good. And then the final point, reason number 4 to avoid large projects is possible, is there's some question of whether making a project larger even works. Now, I want to be careful how I describe this because this data set is pretty specific data set. It's not generally applicable, but it makes an interesting point. Larry Putnam took a look at projects that were business systems projects, all at a size of about 100,000 lines of code. And what he found was that if you have a team size shown on the left of somewhere between 1.5 and 3 people, then you get the effort level shown by the red and the schedule level shown by the green. As you increase the size to 3 to 5 people, team size goes up, and so total effort goes up, schedule goes down, which is what you would expect. As you increase team size to 5 to 7 people, now bearing in mind that these are all for the same size system, schedule goes down slightly, but total effort goes up more. Now, what's really interesting is what happens when you increase the team size above 5 to 7 people. When you increase team size above that level, schedule doesn't go down, it goes up, and effort goes up a lot. And when we try to do that same amount of work with a larger team size of 15 to 20 people, the schedule drops slightly, or is basically about the same, and effort goes up tremendously. So within a certain size of deliverable, 100,000 lines of code, it's questionable whether scaling or making the project bigger works at all. Now, that's not a super generalizable point because this doesn't relate to the idea of bigger team for bigger project in terms of lines of code, but it does shed some light on the idea of what happens when we scale all other things, scale the team size, all other things being equal. Guru's secret number 3 is that agile development does not make scaling more difficult. And I think that's an interesting secret because the title of this talk is really about agile scaling, and I think the common perception in the industry is that we're having problems scaling agile projects specifically. And I think that really is just not the case. And I think if we take a look at how we got into the situation of wanting to talk about agile scaling, that actually makes pretty clear why this is true. You know, the old days, pre-Scrum, pre-Agile, we found that even small projects were often problematic. Companies routinely failed even on projects of 5 to 10 people. But what we've seen is that as organizations have adopted Scrum in particular and become more successful with that, then they feel they're more successful on small projects with Agile than they were previously. And what that leads to is wanting to extend that goodness of Agile, which is making them successful on smaller projects, to their larger projects. And that, in turn, implies the idea that the fact that the small projects are more successful than they used to be makes scaling easier, not harder. And to put that another way, if we have high-performance small projects and we can compose a larger project out of high-performance, reliable small projects, that is going to support scaling to those larger projects, whereas if we had low-performance small projects and we were trying to assemble a large project out of low-performing small projects, that would make scaling difficult, or in many cases it would just make it not possible. The next secret that I'd like to talk about is this idea of sometimes it's more easy to solve the general problem than it is to solve a more specific problem. And this insight is described in some detail in Polya's book, How to Solve It, which is a classic book that's, I think, more than 50 years old now. But I think what we see is that, in my mind anyway, the problem of scaling applies across more dimensions than just scaling Agile. Scaling any kind of software project, Agile or non-Agile, is a challenge and has some attributes to it. Maybe it's easier to solve the general problem of scaling than it is to solve the problem of Agile scaling specifically. Let me give you some examples of that. One pattern that we see over and over again is that companies, as they grow from small to large. And this is just kind of the way it works. If a company is a startup company, creates some software, and the software does well, over time the software will be expanded and built on and add more functionality and support more kinds of users, maybe more devices, more environments. And so the software grows over time, and the company typically grows over time as well, or the software team grows over time. This is not just growth of a company, it could be growth of a product, software product within a company. And we typically see that as companies move from smaller projects to later versions of larger projects, even on the same product, those larger projects will struggle more than the smaller projects did. And this is an issue of scale. The reason that the projects struggle is because of the larger size. Another example is pilot projects. Pilot projects are virtually always small. The nature of a pilot is trying something small to see if it works, and then we're going to try it in the large if it works in the small. And so we have a successful pilot that leads to a larger scale rollout, and then often those larger scale rollouts are seen as problematic. And then companies scratch their heads and say, well, how come this larger project was problematic when the pilot project was so successful? And part of the answer is that the projects are not the same size. The pilot project is small. It's easier to be successful on a small project. The larger project is not, the later project is larger, not small, and the difficulty is attributable, at least in part, simply to the fact that the later project is larger. Another example is use of new technology. We often start projects in new technologies small, trying out the new technology. If those projects are successful with the new technology, companies try increasingly larger projects with the new technology. And what's interesting here is that as this is going on, the technology is becoming less and less new. In other words, it's becoming more mature. And so based on the maturity of the technology, you actually expect that over time, the projects would become easier due to the maturing of the technology. But what often happens is that the projects become more problematic even though the technology is maturing. And the reason that the projects become more problematic later is that they are larger than the earlier projects. And so this project size dynamic is a significant dynamic. And in this example, it actually is more significant than the effect that you get from the maturing of the technology. So you get essentially a decrease or an increase in difficulty due to size, a decrease in difficulty due to more maturity, and the net is that overall you get an increase in difficulty because the size factor actually dominates the maturity factor. Last example is use of methodology. Same kind of thing, same dynamic here. If we try out a methodology and it does well on small projects, people then want to apply it to larger projects because they want to spread that goodness that they've seen on the large projects over to on the small projects over to the larger projects. At that point, the challenges increase, and so then we have people making claims like, oh, well, maybe this methodology really didn't work that well. But really, I think that's a misdiagnosis because what they're really seeing is that it's not so much that the methodology didn't work very well, it's that there were some issues related to size that did not get adequately addressed. And that really leads us to where Agile is today, where we see numerous examples of consultants and companies trying to take the methodology of Scrum or other Agile practices and scale that up. And that's just a natural dynamic, I think, but then we see some challenges arising from size. The next concept I want to talk about is that the key challenge of software scaling is the non-linearity of software project challenges. And this is really an important point to understand. That when we get into a larger project, from a software development point of view, a large project is more than just X number of times a small project. So if we have a small project and then we have a large project that's 10 times as big, we can't just multiply everything on the small project by 10 and expect that to work. And the reason for that is that some challenges, activities, solutions on projects scale linearly, so we literally could just multiply them by a factor of 10, and those particular attributes would work okay that way. But some attributes scale non-linearly, meaning if we have a project that's 10 times the size, we can't just multiply by 10. We might have to multiply by 15 or 20, and we might have to introduce some other kinds of practices that we don't even see or need at smaller project sizes. Since we're talking about Agile scaling, I think it's amusing to put this in terms of scaling the chicken and pig. And if we wanted to have 10 times pig and a chicken and 10 times as much pork or chicken, we wouldn't just be able to multiply those animals by 10 and have animals that are 10 times as big. We actually need to introduce something that's different. It doesn't just scale in a linear way. So what we see is that in addition to the nonlinearity of things scaling maybe more than a factor of 10, we see new challenges emerging over time. And we can see that in each of the examples I gave a few minutes ago. As company software grows over time and we get an established customer base, there are new challenges that emerge from that. as we roll out after that successful pilot project, there are different kinds of projects or challenges that come up in larger application of whatever we're piloting. Same thing, same dynamic for new technology, same thing for larger Agile projects. It's not just a bigger lift of the same thing, it's a different kind of lift in addition to being a bigger lift of some of the same kinds of things. I think it's also useful to point out that if the problem is scaling nonlinearly, which it is, the elements of the solution are going to need to scale nonlinearly too, and I think it's really useful to bear in mind that we have both a problem and a solution, and both of those things are scaling, and the connection between how the two of those things scale is not necessarily a super direct connection, and understanding that I think is important. When we talk about the nonlinearity of software project challenges, one of the things we need to understand is the idea that software has this thing called a diseconomy of scale. Normally when we talk about diseconomy of scale, we don't even use that word. We talk about economy of scale, where we say if we have a manufacturing plant and we build a bigger manufacturing plant, our unit cost goes down, and that would be an economy of scale. In software, we don't get an economy of scale. As our project sizes go up, our unit cost goes up, not down, and that means we have a diseconomy of scale. And what that means specifically is that on larger projects, per person productivity decreases, and that's a factor that a lot of organizations don't really account for. The diseconomy of scale is worth dwelling on a little bit. If there was no diseconomy of scale, as project size increased, shown on the x-axis, the unit cost would stay the same. If we had an exponential diseconomy of scale, we'd see a curved line that increases dramatically faster than no increase. We don't really see that in software. It is exponential, but it's a mild exponential function. And so we have really kind of a mild diseconomy of scale in software, where as project size increases, the unit cost goes up, but it goes up fairly slowly. So if we're looking at a difference in project sizes of a factor of 2 or 3 in the difference size in the size difference, not that big of a factor, but when we start talking about doing projects that are 5 times the size or 10 times the size, then it becomes a factor we really have to worry about. This graph shows the diseconomy of scale as continuous, meaning a smooth line. I actually don't think it actually works that way. I think how it really works is more as a step function. And so my view of diseconomy of scale is that the diseconomy is essentially about the coordination overhead that we need to introduce on software projects to keep all the work flowing in a coordinated way. The specifics of the coordination work really depend on the nature of the project, and I think this is one thing that the different scaling frameworks in Agile miss, is that on some projects, really the bulk of the coordination work is management, and that's what we need to coordinate. On a lot of projects, I think the bulk of the coordination work is actually requirements, not management. Coordinating the requirements work among different teams is actually the dominant feature of the project. On some projects that are more state-of-the-art or more technology-focused, we can actually have architecture work that is more the defining challenge of the project rather than requirements. And on some projects, maybe process is the defining attribute that's difficult to scale. I actually think that one's not really that common. I think requirements is most common. Architecture might be second most common. I think this is one reason that practices like Scrum of Scrums that are really focused on process as the thing that we need to focus on as we scale is kind of solving the wrong problem in a lot of ways, because the thing that's not scaling is typically requirements or architecture, and process really isn't that commonly that much of a challenge. And then what we see is that we get higher defect rates, which leads to disproportionately increasing defect correction effort as that project scales up, due to the need to have higher levels of coordination among these activities, but also the error rate that arises from mistakes in that coordination work as we scale up to larger projects. And I think what this leads me to believe is that this economy of scale in software ends up really being a step function, meaning it's not a smooth line, but there are steps at which additional levels of coordination need to be added, and that's where we really get a jump in or a drop in unit productivity or per person productivity. And I think this is mostly a powers of 7 idea, where we have about 7 people on a team. This is kind of the nominal size for a Scrum project. We have a leader, we have 1 leader, 1 Scrum master, or the team could even be self-managed. Once we get up to that next power of 7, about 49 or 50, at that point, we actually have to have multiple leads, multiple Scrum Masters. We have to have coordination among the Scrum Masters, coordination among maybe the leads, coordination among the architects, and significantly, we need to have somebody sitting on top of those people coordinating their efforts. And so that's that extra level of coordination. And then we can kind of get by with that one level sitting on top of that until we get up to a size of about 250 to 350, so that next power of 7. And at that point, we typically add a layer that's above the layer of architect or above the layer of director, where we end up having like group managers or a chief architect on top of the architects or a VP that sits above the directors. So we end up with that extra coordination work. And so, you know, I think it's important also to point out that as we scale on projects, it's not just that we're doing more of the same kind of work. We're doing more, we're doing new kinds of work, including new kinds of coordination work. And so I think what that leads us to is that productivity is not a smooth line. Per person productivity is not a smooth line that decreases as project size gets larger. There are actually some drops at specific points where we have to increase levels of coordination overhead, and that's really where we see a discontinuous drop in productivity. And so if we look at the output curve, what we see is that their output increases more rapidly until we get to those points of discontinuity, and then we may have a little drop where maybe it doesn't even make sense to have a team of certain sizes because we have to add overhead, and the overhead costs us more than the additional output. But then as we move into the next part of the line, the slope of the line shifts, and it's not as steep as we add people, so output isn't increasing as quickly, and then we get larger and larger, and we get the same dynamic at different sizes of projects. So then this is really that dynamic that the company founder I mentioned at the beginning of the talk was seeing, was that when it was just him and two guys in the garage, they could have a really rapid increase in productivity as they added each incremental person. As you get out to larger and larger teams, each person that you add doesn't add anywhere near as much output as it would at smaller project sizes, and that can be quite frustrating to organizations as they get larger and have misaligned expectations about how much each new person is going to be able to contribute on their projects. So, and I think I've pretty much talked through this slide, but if you review the talk later or get a copy of the slides later, this is just here for your reference. So let's apply this to Agile scaling in particular. I think problem number one with the diseconomy of scale is that planning large projects as though the diseconomy of scale does not apply is problematic, because it does, and if we just assume that we can do a project that's 5 times as large by doing 5 times as many of the same activities, that's not going to work. And the other problem we run into is it's not accounting for the step function, which is not realizing that there are certain boundaries, that project size boundaries that apply, and as we cross those boundaries, we have to be aware that we're crossing a boundary and need to do something different as we cross those boundaries. Now, this brings us to the very interesting point that for many years, the idea of a holy grail of project scaling is being, can't we conduct a large project as though it were a series of small projects? And yeah, that would be fantastic. If we could just take our large project, chop it up into a bunch of small projects, and run each small project with no penalty from the diseconomy of scale, that would be fantastic. We wouldn't even really have to worry about scaling. And the challenge here is that to do that successfully, we have to partition the work so that we can truly run each of those small projects as an independent small project. And to the degree that we can't do that, that actually undermines our ability to run those small projects as truly small projects. And as we add coordination about architecture and coordination about requirements, then yeah, we get some benefit out of good partitioning, but we don't really have independent small projects, and so we don't get the productivity we would get out of having a bunch of small projects rather than one large project. And this brings us to the relevant topic of Conway's law, which is the idea that the structure of a system will reflect the structure of the organization that built it. And so this applies to lots of different areas, including multi-site development, but also applies to large projects. And for us to have these parallel small projects work effectively, we have to partition the work. That also means we have to partition the project teams, or really the opposite is also true. To partition the project teams, we actually have to partition the work at the software architecture level, and the software architecture really therefore must support the human organization. And this is a little problematic for Agile projects in particular, because this requires a focus on software architecture early in the project, before most of the human teams are even staffed and organized. And for many Agile projects, they consider that to be an unnatural fit. The idea that we're going to do significant software architecture work early in the project is really seen as anathema to in some Agile circles. But to have a large project that scales successfully, that's something that we actually need to look at earlier rather than later in the project, in part so that we can support the human organization of the project. There's a software design quality aspect to looking at architecture, but there's a human organization aspect to looking at architecture, and both of those matter as we start to scale our projects. So I think this is worth attempting. I think even on Agile projects, it's worth attempting some work on early architecture. You know, this has been problematic over the years. We tend to be somewhat error-prone and not very omniscient about how these things are going to work out, but I think it's still worth the attempt. It's better to get close and have some errors than to not even try and not get very close. So to summarize, I think we've seen that large projects are difficult. One of the keys is to avoid scaling if possible. Agile practices actually make large projects easier, not harder, at least if they're done well. I think the general problem of scaling is probably more significant than the problem of Agile scaling, in part because I think Agile actually makes the scaling challenge easier, not harder. But the key point here really is this one, that software project challenges scale non-linearly, and so understanding how they scale non-linearly is really important. And so that's what I want to turn to in tool number 2, which is application of the Cocomo 2 model to understand the ins and outs of scaling and what challenges scale non-linearly. The Cocomo 2 model is mainly known as an estimation model. I don't think it's all that useful for estimation purposes, actually, not really due to any fault of the model, but more due to how the model gets used in practice. However, I will say that I think the statistical analysis that's gone into understanding the impact that different factors have on software project outcomes that's been done with the Cocomo 2 model is probably the most rigorous and reliable statistical work that's been done in the software industry so far. And so this slide shows the impact that the 22 different Cocomo factors have on project outcomes, where the bars show the different impact that for projects of a given size, so size held constant, how will the project outcome vary based on the worst performance on this factor or the best performance of this factor? And we're not going to talk through most of the factors, but I'll call your attention to the 5 factors that are shown in red or dark orange. Those are known as scaling factors in the Cocomo model. And what's interesting about these is that most of the factors in the Cocomo model are linear, meaning whatever the size of the project is, the factor applies to the same degree. So that product complexity factor shown at the top of the list, if your project is 10,000 lines of code or 10 million lines of code, it applies to the same degree. But the 5 factors shown in dark orange or red do not apply to the same degree. Those scale non-linearly as project sizes increase. And so let's dwell on those for a few minutes. Those 5 factors are precedentedness, and we'll talk about that in a little bit of detail momentarily, process maturity, architecture and risk resolution, requirements flexibility, and team cohesion. And just to show you how important this is, from the Cocomo 2 model point of view, on a relatively small project, this is drawn from the point of view of a project of 100,000 lines of code. So it's not a tiny project, but it's not huge either. These 5 scaling factors shown with the dark orange bars, none of those are in the top half in terms of influence on project outcomes. But on a larger project, now drawn from the point of view of 5 million line of code project, all 5 of those factors are now in the top half of the factors in terms of influence on software project outcomes. And so this is significant because what this says on small projects, it's actually pretty safe to ignore these factors. But on large projects, you can suffer greatly if you ignore these exact same factors. And so this just reinforces the point that really the factors that challenge projects change disproportionately or non-linearly as project size increases. And what we see here is that as companies scale their projects from large to small, they typically will run into challenges or even have failures as they first attempt larger projects. And the natural response to that failure is to try to repeat the practices that made them successful on small projects, but just repeat them harder or with more commitment or with more fidelity or just to try to do them right. That's a very natural response, but that response doesn't really work because it's not addressing the factors that are different or that have changed at scale, that matter now that didn't matter at smaller project sizes. And so this idea, I think, is neatly summarized with the phrase, what got you here won't get you there. Small project success does not completely prepare organizations to succeed on larger projects, and so understanding some of the factors that are different on larger projects is really critical to understanding what can make you successful on larger projects. So let's just look briefly at each of those 5 Cocomo scaling factors and see what we're talking about. The first one is precedentedness. We don't usually use the word precedented, we usually use the word unprecedented. But precedentedness refers to how familiar is the application of the technology being developed. And on small projects, we can overcome challenges due to unprecedentedness fairly easily just through a little bit of extra effort. But on large projects, we really can't do that. It becomes the third most important factor on large projects. And so what this says is that if you're trying to do a large project that is working in an unprecedented area, that the challenges are just going to increase significantly. And in terms of my 4 factors lifecycle model, what we're seeing here is an interaction between the 2 factors of size and uncertainty. And if we're getting challenges from size and challenges from uncertainty, that becomes problematic. And we either need to work really hard to address that, or we just need to not take on both of those issues at the same time. The second factor is architecture and risk resolution. And that really refers to the number and severity of the risk that we can identify, also the extent of activities that are focused on risk management, but also, as I discussed a few minutes ago, the extent of the architecture work that we do that supports both design but also the human organization. And interestingly enough here, also the quality of staff that's available to support the architecture work. We actually need not just more of the same people, we actually need people with a higher skill level to be successful as we get into larger projects. And so what this says again is that if we have a small project that is bombarded by risk, maybe we'll be able to overcome that. On a large project that's bombarded by a similar ratio of risks, we have a disproportionately difficult time overcoming those risks as project scales, and we need a different kind of person to successfully overcome those. I think here it's interesting to note that interaction with Conway's law again. You know, as we get into the human organization design and the implications for that on the software architecture, we can see some interesting issues like the requirement to have a team geographically distributed. If that's not addressed in the architecture of the software itself, that can create some mismatches between the design of the software versus the design of the organization. That becomes increasingly difficult to resolve as we get into larger projects. Same thing if we get organizational structures that are a little wonky because of acquisitions and having responsibilities allocated to different organizations in a non-ideal way, that can become increasingly challenging. Basically, I think this slide summarizes what I've already said. Companies struggle where they take on projects where the architecture and risk profiles are just too challenging for a large project. The third of the scaling factors is requirements flexibility, and what that refers to is the need to conform specifically and exactly to pre-established requirements. So how rigid and exact are the requirements? And what this really says is that if we have, let me go back to that on that one. What this really says is that on a small project, we can have really rigid requirements, and it doesn't require all that much work to reconcile the set of rigid requirements and how they interact with each other. But as the project gets larger and we have a larger set of rigid requirements and we have to reconcile how all those rigid requirements interact with each other, we're going to see more cases where it's a lot of work to implement one requirement exactly as specified and all the other requirements exactly as specified. If there's no place we can bend, then we get disproportionately increasing amount of work to make that whole structure grow without any ability to flex anywhere. And so a typical pattern we see is that on greenfield projects or version 1 projects, we tend to have a high latitude in interpreting requirements details. So we get the benefit on a greenfield project of it being small and the benefit that we have high flexibility in requirements. Later versions of systems, just by their nature, tend to have more rigidity in their requirements due to the fact that you have an installed user base, installed customer base, legacy expectations, you've built up a number of other systems that you have to interact with in an exact way. In other words, establish customer and user expectations. And so you get hit from both sides on this, where you have both a larger system and more rigid requirements. And this is a typical growing pain that companies experience as they have increasingly mature and larger systems. So I guess to summarize this point, this is really kind of an interaction between size and defects, where the specific kind of defects we're talking about here are requirements defects. It just becomes more work to correct all those as the size increases. The fourth scaling factor is the idea of team cohesion, and this really refers broadly to how interactions on the whole team are conducted. And what this says is on a small project, we can deal with a little bit of friction among the team members. On a large project, if we have a lot of friction between different stakeholders on the project, that actually becomes increasingly challenging. So we can have, on a larger project, we can have multiple stakeholders who maybe don't all have the same objectives. We can have a difficulty in them actually being willing to accommodate each other's objectives. The stakeholders themselves may not have experience working as a team, and that can insert challenges in a larger project, and it might require more explicit work to develop shared vision and commitments. We can often assume or just do a little bit amount of work on a smaller team to develop that shared vision and commitments, but once we have a larger team, and especially once that team gets spread out across multiple sites and maybe drawing people from different organizations, stakeholders from different organizations, we actually have to do explicit work to develop that shared vision and shared commitments. Basically, I think the other factor we see is that on large projects, a single dysfunctional relationship can create ripple effects that can really go a long way in a bad way through the projects, and this becomes disproportionately problematic on larger projects. The last scaling factor we'll talk about today is the nonlinearity of process maturity. This really refers to how well-defined, repeatable, and optimized your software processes are. And what we see is this doesn't really matter a whole lot on small projects. It's actually, not that big a consequence for teams to ignore it, but as we get into larger projects, this becomes the fourth most important factor. And this is kind of a key point, because especially in an Agile context, adding process feels unnatural, both because it wasn't that natural on a small project and because Agile is not really that friendly to adding process. But as we grow into larger projects, we have to add some process due to the fact that larger projects need it, and this ends up becoming problematic both because it's seen as being adverse to Agile, but also because the people who thrive on small projects often just are the kind of people who don't really want that much structure and process. And so what we see is that as teams grow, a lot of times we'll see, or as companies grow, you'll see that people who were there in the early stages saying things like, well, this is not the same company anymore, this doesn't feel the same, it's lost its entrepreneurial edge. And those statements are probably all true, and they're probably necessary due to the factors that are necessary to be successful on smaller projects. If we think about SAFe, for example, we hear characterizations that SAFe is not really Agile because of the degree of structure, but at the size that SAFe applies, which is nominally around 300 people, that amount of structure is actually appropriate. In fact, we need some kind of structure or other to be successful at that size. I'm not really commenting here or endorsing the details of SAFe, but I am saying that at the 20,000-foot view, the amount of structure that we see in SAFe makes sense for projects of the size that SAFe applies to. So what are the implications of the Cocomo scaling factors? Well, I think what we're starting to see is it gives us some background on why error rates increase as project size increases. It gives us some background on why per-person productivity decreases as project size increases. And what we see is that the sources of difficulty on small projects don't go away on larger projects. They're still difficult, but some of those grow linearly. But we get additional nonlinear factors that emerge and present disproportionate difficulties on larger projects. And whereas organizations often prepare for the linear growth of difficulties that they are familiar with from smaller projects, they often don't prepare at all for these nonlinear factors that emerge on larger projects, and that ends up really being a big source of problems as organizations try to scale. In the last few minutes we've got for the planned part of the talk this morning, I want to touch on tool number 3, which is activities and intellectual phases. This really gives us a way to look at how challenges can scale nonlinearly and a way to look at how our responses and solutions need to scale nonlinearly too. If we take a very abstract view of activities on a software project, say requirements activity, architecture and design, construction and system tests. Which of these do we need to scale? To what degree do we need to scale each of these activities? Do we just scale all of them proportionately, or do we scale more in one area or more in another area? And this leads to staffing questions too. Do I need to scale the product owner role disproportionately or proportionately? What about the Scrum Master role? What about the architect role? What about the developer role? Do I need to add other roles entirely that I don't even have? Well, it's possible that on some projects, I guess in general what we see is that as project sizes increase, the activities that we focus on change. And so this diagram shows a way that construction, shown by the blue area, decreases as system test increases, architecture increases, and requirements work increase. So that might imply that we scale requirements and architecture more than we scale construction, or maybe more than we scale system tests. Or if it varies project from project, it might imply that in some projects we actually have to scale system test more and maybe construction more. The one thing I think I can guarantee you is that we're not going to scale all of these activities proportionately. They're going to scale disproportionately somehow or other. And the big mistake we make is assuming that we can just scale everything at the same rate. And so I think a way to look at this is in terms of what I describe as the intellectual phase view, which is really the idea that projects tend to start out with a focus on discovery or requirements. There's a lot more on this in the Understanding Software Projects lecture series. I'm just going to touch on it briefly today. But we tend to start by focusing on discovery or requirements, then we move into invention or design, and we finish mostly with a focus on construction. And there's definitely some overlap in activities, and certainly the more agile approach we're taking, the more overlap that we strive for. But there's always going to be some overlap in these different activities. And I think one way to look at where the challenges might come from is to look at this model and to say, you know, in some projects, really the challenges are going to come mainly from requirements. And that implies we ought to scale our response and requirements more than in the other areas. Some other projects, it may come from design, and that means we scale the design work differently. In other projects, it might come more from construction, so we scale that differently. And of course, it can come from pairs of these as well. It can come from requirements and construction, or requirements and design, or design and construction. And so thinking through the scaling using this model, I think, can give us some insight into where we ought to anticipate disproportionate challenges as we scale. Well, I think with these three tools in our pockets, we can now summarize the secrets of the Agile scaling gurus. I think as I've talked, if you've ever heard any other talk I've given on Agile, I think the common discussion often treats issues in Agile as though Agile is really the main factor we have to be concerned about. So it's really Agile scaling. But I think when we really unpack where the issues are coming from, in this case, I think it's a lot more productive to treat the scaling issue as though really the emphasis is on the scaling. Yeah, the Agile part matters. It changes some of the details. But the challenges are mostly coming from size, generally considered, not from the fact that Agile is part of the mix. Large projects are difficult just by their nature, not just Agile large projects. We've seen that problems scale nonlinearly. The solutions need to therefore scale nonlinearly too. And if the Agile implementation has been done well, if we have individual small-level Scrum teams performing well, that actually makes the scaling challenge easier rather than harder. And so if we can think about the tools that I presented in this talk, the 4 factors lifecycle model, specifically focusing on size, and there's a lot more to it than I presented in this short talk. You can get all that in the Understanding Software Projects lecture series. I would encourage you to do that. The Cocomo 2 model also gives us some insight into specific factors. It's not the entire list of factors, but it's certainly a good starting set of factors that become different as project sizes increase, and then that activity and intellectual phases. I'm not going to talk through all these details in this talk today, but if we really look at the interactions of the 4 factors lifecycle model with size, it can give us some really interesting perspective on what kinds of factors we need to be aware of. And you can get a little bit of insight from studying this slide, way more insight from actually going through the lecture series. The other thing we can do is actually take a look at our 4 factors model and how that gives us candidate responses to consider in terms of that intellectual phases model of different responses that we might consider in discovery, invention, and construction. So again, I would encourage you to check out the Understanding Software Projects lecture series. You'll get a link that allows you to access that for the next 90 days by virtue of attending this lecture in person. And at this point, I will go ahead and turn the mic back to Tracy for questions.
Great. Thank you so much. You provided a ton of information. I really appreciate that, and I'm sure the audience does too. So let's move ahead. And the first question is, what is the one factor you've seen that most often contributes to problems with scaling?
Yeah, well, it's an interesting question because in a lot of ways that's like the whole talk. But, you know, I think if I had to summarize, I would say the one factor is probably just not recognizing that scaling itself presents challenges. You know, if I have a project that's 3 times the size or 5 times the size, I don't just hire 5 times the number of people. I have to change my approach. And so lack of understanding of the fact that size on its own is a significant factor, I think is the most significant issue.
Okay, great. I have another question, and it says, if you go back to your slides on diseconomy of scale being a step function, in parentheses they say, I think it was slide 45, how do those steps relate to the common Agile scaling framework?
Okay, so we'll go back to that slide. Yeah, so I think that's an interesting question, and I think it actually does relate to the Agile scaling frameworks, because I think although you don't really see this addressed explicitly, you kind of hear things like, you know, Nexus might apply to team sizes of, you know, on the order of 50, or SAFe might apply to team sizes on the order of 300. There's not a lot of discussion of the idea that, well, why does it apply at that size? And I think the answer is basically this idea of there being a step function in diseconomy of scale. You know, if SAFe applies at that 300 size range, what it's really saying is it applies to a certain size organization where we have organizational attributes of a number of layers of management and coordination overhead, whereas an approach like Nexus might apply to a smaller scale where we have fewer number of layers of management, coordination, and overhead. And so, you know, people can tend to look at it and think, oh, maybe it has to do with the technical practices, or maybe it has to do with this, that, or the other thing. But it really, I think, has to do with this diseconomy of scale due to the step function that I presented in this talk.
Okay, let's see. Here's another one. What is the reason that error rates go up so much on the largest projects and productivity goes down?
What is the reason that error rates go up so much on the largest projects and productivity goes down? I think it's just really due to all those factors that I talked about, where as the work becomes more complex and you get more interactions between the work, you get basically you get more mistakes due to the fact that the coordination is more complex and there are just more moving parts and therefore more interactions among all those moving parts. And so that's really why the error rate goes up. And then the productivity goes down, partly because of the increased levels of coordination, but also partly because of that increased error rate. And so that increased error rate ends up manifesting in 2 ways. One is we have more work that goes into actually identifying and correcting the errors. And the other way is that we put more effort into preventing the errors in the first place. And we really need to do that on larger projects. So those, I guess the key point there is that those dynamics of error rate and reduced productivity are very strongly interconnected.
Okay, thank you. How about, what is the optimal organizational structure for managing and implementing large software projects?
What is the optimal organizational structure for managing and implementing large software projects? Well, I'm laughing because I think as the years have gone by, we've seen so many organizations move away from the optimal structure for that, which involves significantly having teams co-located in the same facility. And I mean, this is painful in a way because I would say the vast majority of larger companies that my company, Construx, has worked with over the last 10 years at least, have teams at multiple sites, and often their projects are therefore also being conducted at multiple sites, with no real understanding of the implication of trying to conduct a large project across multiple sites. But if the question is optimal, I mean, we can make it work no matter what. We can do a large project across multiple sites, and lots of companies are doing that. And if we have the constraint of multiple sites, we can adjust the software architecture to do as good a job as possible on that. But it's not going to be ideal. And since the question is optimal organizational structure, I think the optimal structure is having everybody in the same building, on the same campus, in the same time zone, doing their work together, and that makes a huge difference in terms of just incidental conversation, clearing up issues in a timely way, not having wait states and people getting their questions answered, not having wait states and getting defects corrected, and so on. So, co-location, even for a really large project, is, I think, the ideal.
Okay. Sounds good. Now, we've sort of run out of time here, Steve, so would you like to add any closing comments before I shut it out?
Sure. Well, I'll just say thanks to everybody who attended today. It's great to have such a large audience today, and appreciate the questions that people provided. And again, please check out the Understanding Software Projects lecture series. There's a lot more to it than was presented today. And if you found the comments on size today, I think you'll find the other comments in the lecture series useful as well.
Great. I hope everybody takes advantage of that. And so, Steve, thank you so much for your presentation and for your Q&A. As always, very well done. And I'd also like to thank the audience for attending the webcast sponsored by Construx and presented by adtmag.com. Thanks again, everybody, and enjoy the rest of your day.